We've gone from product to sum, so which means we can go from sum to product. So 4 more identities for you to kind of latch on to. Again, just want you to be aware of them. Use them when we need to. And how we kind of use these a little bit or could use them. Let's just look at an example here where I have the sine of 9x plus the sine of 5x. So how can we take that sum and convert it into a product? I look with an appropriate sum to product formula. It's the top one. Then this becomes 2. Sine of alpha plus beta, which is a 9x, plus a 5x, all over a 2, times the cosine of 9x minus 5x, all over a 2. Clean that up a little bit. 2, 14x over a 2 times the cosine of 4x over a 2. And then lastly, 2 sine of 7x cosine of 2x. So we basically took the sum of two sines, so the sum of two angles, and converted it into a product of our trigonometric functions. Another one, let's see what we can do with this one. Might let you guys just do it. I just might stand back and watch. So we have the cosine of 4x minus the cosine of 3x. How do we take that sum, which in this case it's a difference, but sum and differences are just cousins of each other. Looks like it's this bottom one right here. So this should equal minus 2 times the sine of 4x plus 3x divided by a 2 times the sine of 4x minus 3x divided by a 2. Work it through. That's a 7x divided by a 2 times the sine of x divided by a 2. And I think I can stop right there. And again, took a sum and reworked it into a product. Now let's look at how to verify an identity by usage of our sum to product formulas that we have. Notice that I have a difference of cosines on the top, on the numerator, and I have the summation of sines on the denominator. So let's just rewrite those in terms of our sum to product formulas. So my numerator then becomes minus 2 times the sine of alpha plus beta, which is a 3x, plus a 5x, all over a 2, times the sine of alpha minus beta, which is a 3x minus a 5x, all over a 2. All right, I think I'm fine with that. There's 4 of them up there, and I'm always looking to the right one to making sure I write down from the correct one. The denominator is the additions of sums or of sines, so it's 2 times the sine of alpha plus beta, which is a 3x, plus a 5x, all over 2 times the cosine of a 3x minus a 5x over a 2. All right, let's clean it up a little bit if we can. Negative 2 times the sine of 3x plus 5x divided by 2 is a 4x. Sine of, I have a negative 2 over a 2, which is a negative x. Then I have in the denominator a 2 times the sine of, again, it's a 4x, and a cosine of a negative x. All right, what are some things that I can do right now, it looks like? Well, there's a couple of things. It looks like I can go ahead and factor out this 2 and that 2, and this sine of 4x and that sine of 4x. So let's clean it up a little bit. So that's 2 negative times the sine of negative x all over the cosine of negative x. Okay, I think I can get to tangent of x is where we're going for. Do you remember the sine of negative x? That's the same thing. I already had this negative. That right there is also the same thing as the negative sine of x. And cosine of negative x, that's also the same thing as the cosine of x. If you remember our even odd identities, so minus times a minus is a plus, so that equals the sine of x over the cosine of x, which is one of our identities for the tangent of x. All right, identity verified.